let's look at histology, which is just the study of tissues. You know, we go back to our levels of organization from chapter 1. The atoms and molecules, or chemical level, make the cellular level, and the cells make the tissues. So all tissues are made up of cells that are related because of the job they do, their structure and function. And around the cells, there's a material that's called the extracellular matrix, or the ECM for short. There's 4 main tissues in the body, and we classify them by how many cells, the kind of cells, the composition, and the amount of extracellular matrix between the cells, and other functions. There's epithelial tissue that you're going to find on coverings that lines your body surface and lines all your cavities in the body, and it also forms glands that secrete things. There's the second type, connective tissue. This is what connects. It binds and supports and transports and protects all of your other tissues. Muscle tissue, this is made up of cells that can generate a force when they contract. And then the fourth type of tissue is nervous tissue. And that's what you find in your brain and your spinal cord and your nerves. And it helps to make and send and receive messages. So there's 4 main types: epithelial, connective, muscle, and nervous. Now looking at this extracellular matrix, that's the stuff around the cell. It is liquid or thick gel, or it may even be solid like in bone. And it goes around the cell, and it's got 2 main parts. It's got a ground substance, and it's got protein fibers. The reason you have an extracellular matrix is to give a lot more strength to the tissue so that it doesn't stretch and compress too much. It also helps the cells stay where they need to be in the tissue, and it regulates the development of the cells and their mitotic activity and their survival. So we need the extracellular matrix. And some tissues have a lot of extracellular matrix, and some tissues don't have much at all. Now, we said it was made of 2 things: ground substance and fibers. The ground substance is most of the extracellular matrix, and it's made of extracellular fluid or interstitial fluid. And that fluid's going to have water and nutrients and ions in it. There's 3 families of macromolecules, big molecules there. There's the glycosaminoglycans, and that helps to trap water in the extracellular matrix so that it resists compression. And there's also these same macromolecules, glycosaminoglycans, create a concentration gradient to draw water out of the cells and blood vessels. The second in the ground substance macromolecule is the proteoglycans. And they are going to make the extracellular matrix firmer and more solid to resist compression. And it also makes a barrier to keep substances from diffusing through it. And by doing that, it's protecting the underlying tissue from any kind of invading organisms that might want to get through. The third is the cell adhesion molecules. And these are just glycoproteins. Glyco means sugar, a sugar protein. And they hold the cells to their surroundings and hold everything in place in the extracellular matrix. And so it helps with the structure or the architecture of the tissue. Now, the protein fibers that are there are embedded in that ground substance. And they can be large and rope-like and have a lot of tensile strength, or they can be really thin and not much use as far as tensile strength, but they're good to make a netting or a support, a web-like arrangement. The first type of fibers are collagen fibers. And this is about 20 to 25% of all the proteins in your body. You have this white fibrous protein, and you have lots and lots and lots and lots of it together to resist a lot of pulling and tension and stretching and pressure. This is what you would find a lot of in your tendons and ligaments. I always like to use the analogy of the big rope that you used at field day when you were in elementary school for tug of war. You couldn't break that rope because it was made of all these fibers that were woven together. That's what collagen fibers are like. It's a big bunch of these fibers woven together. And then you have elastic fibers. And of course, they have this protein called elastin in them that helps it stretch. And it can stretch as much as 1.5 times its resting length and not break. And then when you let it go, it goes back to the original size. It's elasticity. And I compare this to a rubber band. You can stretch it, but when you let it go, it goes back to the original size. And then the reticular fibers. Now, this is like you took one really thin collagen fiber and you made a web-like arrangement with other collagen fibers that are thin like this. And so that gives support and helps also make a trap for foreign cells. So those are the three types of fibers that you find in the extracellular matrix. So you got your ground substance, which is that blue background that you see. And then you've got your big, thick collagen fibers, and you have your elastic fibers that stretch like a rubber band, like that one right there. And then you have the reticular fibers, these really thin ones back here. Those are your reticular fibers, and you see how they have to weave to make a strong arrangement. And then within that ground substance, that blue background, you see the proteoglycans and the glycoproteins that form the barrier to keep bad things from getting in and out of the cell, and the glycosaminoglycans. You see all that embedded in that ground substance. Now, we talked about how cells have to communicate with each other. But in tissues, your cells have to be bound together, and so that the neighboring cell plasma membranes are connected. And you have these proteins that help with that. And they form tight junctions, desmosomes, and gap junctions. Now, the tight junctions, they look like this, okay? They hold the cells really close together, and they're so close together that they're not going to let very much get through. There's not going to be a lot of movement happening from this cell over to this cell because of these very tight junctions here. And there may be some leakage, but you find this in the cells of your blood vessels. And that's what keeps your blood in your blood vessels. It can't get out. The blood cells are too big to get out. Then you have desmosomes, and desmosomes look like a zipper, like this. And they are linking the cells together. It increases the strength of the tissue because it holds those cells together. And you're going to find this in tissues that have a lot of mechanical stress, like in your skin. And it will allow a few materials to get through, but not much. The third type is your cell junctions, is the gap junctions. Now, this is one cell and this is one cell, okay? So the gap junction is like if we had a straw and we put it through here, to connect the cell membranes to each other, but a straw is hollow. And so substances can actually go from this cell and go through that to the other cell. So the gap junctions give you gaps or spaces for stuff to flow more freely throughout the cell.